Hello, welcome back. All right, guys, two more classes to go. We are almost done with the school year. This is exciting stuff. All right, so we're going to end correlations unit as quickly as we started it, pretty much with 2 days practicing something called prediction intervals. Now, I think these are pretty much the coolest math things that you can learn at an introductory level. What they allow us to do is make predictions, hence the name. And they're very similar to margin of error, so we'll get right into it. And we'll get started with what we already know. And then I'll teach you guys how to do prediction intervals. So here we go. So let's take a look at some data I gathered. Let's just say I sampled a certain amount of guys, asked them, hey, what's your shoe size and how tall are you? And then wrote down those numbers, okay? So it starts with two data points, right? So you ask a person a question and then a follow-up question. And last time, again, the important part was we went ahead and learned a couple things. We learned how to go ahead and take a look at the scatter plot, and using spreadsheets, we learned how to go ahead and set up a trend line, and then, or best fit line, you can call them, along with a equation and everything else, right? So we learned that last time. We also learned how to go ahead and get what is known as the correlation coefficient. So I'm going to get the correlation coefficient of this data real quick. And again, I do that by dragging my first variable, in this case shoe size, comma, my second variable, in this case, the height of each of those men. So as you can see, the most maximum correlation you can have is 1, meaning it's 100% correlated. 0.92 is very, very good. It's very, very high correlation, as you can tell by the scatter plot. Dots are extremely tucked in to the best fit line. So you can see that there's definitely a correlation, not necessarily causation, definitely a correlation between, obviously, the bigger your foot size, the taller you are. So today, let us begin with this prediction interval mess. Now I'm going to leave this equation up here momentarily because we're going to need that in a second. Hopefully this will make sense. There's 6 steps to this process, and by the end, hopefully you can try a couple on your own. So here we go. Let's get started. So steps to complete a prediction interval. This is where you're going to want to either take a picture, or you want to take a screenshot, or you want to go ahead and take some notes. The 6 steps go as follows, and I'm going to go through each of those steps one at a time. Now, don't get too freaked out by some of these formulas. We're going to be doing a lot of this heavy lifting on using graphing calculators, as well as using spreadsheets. And I know you might be like, well, I don't have a graphing calculator. Don't worry, I got you covered. I'll tell you more about that in a second. So the first step we're going to do is get degree of freedom. Second step is we're going to get what is known as the regression equation, which we actually already know how to do. We did that by doing a spreadsheet on doing a scatter plot on a spreadsheet. You already get the equation of that best fit line. So that's technically what step 2 is all about. Now it's asking us to get what's called a point estimate. I'm going to show you what I mean by that momentarily. So honestly, first 2 steps, not hard. In fact, third step, not hard either. It's going to be getting a critical t-score using a t-table. So all of these things are things you should know how to do. Now, the math part, this is the part that freaks people out, but hopefully going through the paces with me, you'll be able to figure this out. The first step in the math part is what's known as the standard error. I'll tell you more about that when we get there. And then number 5 is going to be the margin of error. Like I said, this is very similar to a confidence interval problem, where you would take the margin of error and add it, subtract it. It's either the mean or a percentage that you were trying to predict. In this case, we are trying to predict a certain value, and this margin of error will be the plus or minus that will give us our range that our prediction would be in. Now, lots of weird symbols in here. Some of these should be familiar to you. Some of these will be something that I haven't talked about in a minute. For instance, the sigma symbol, which again means sum. We'll get to that momentarily. And then last but not least, the last step, which would be adding and subtracting to get your final prediction interval. So this does look like a lot at first. When we break it down by steps, hopefully this will make it a little bit more manageable. So let's get started with step 1. All right, before we do, here's the problem. So the problems are going to look like this. Construct a 95% confidence interval. So 95%, that would be the percent probability that your prediction is correct. For men's height, if their shoe size is 11.5. So what we're going to do is we're going to take pretty much all the data we have, and if you look at the data that we have, none of the people there have a shoe size of 11.5, so we actually have no kind of height to match it. So we're going to see what that prediction would actually be. That's pretty much what the problem is. So that's what they're gonna give you. Pay close attention to the confidence level and, again, the value that you're predicting for. Okay, in this case, 11.5. More on that momentarily. So here's we go. First step is to find the degree of freedom. The degree of freedom is just your sample size minus 2. So in this case, if you take a look at it, I know it says 17 here, but I used one of these rows for the titles. So technically we have a sample of 16. Now it's not all the numbers. That's not your sample size, it's the number of pairs. So in this case, how many rows of numbers? So 16. So we would take 16 minus 2, and 16 minus 2 is 14. Step 1 is accomplished. That's the degree of freedom. We'll come back to that when we get the t-score. That's it. Step 2 is to do what is known as a prediction. It's pretty much what you did before and stuff that you've done in other science classes before. It's just use the best fit line equation to make a quick prediction based on what you want to find out. So we have our input, or we're trying to figure out the shoe size of 11.5, how tall a person is. One way we could do that is just plugging it into this equation right here. So by plugging in that equation, it's going to pop out what height that shoe size is associated with, at least for our best fit line, right? So for instance, 11.5 is roughly here. So where is that line at? What Y value is matched up with that? And the best, easiest way to do that instead of eyeballing it is just to plug 11.5 into that equation. So that is what step 2 is all about. The problem that you, or the number that they give you, you're just plugging it into the best fit line equation and getting your prediction. So this is the prediction part of the prediction interval. So you got the 1.84, which is again, just coming straight from the equation on the spreadsheet, plugged in the 11.5, add it, do that on your calculator real quick, and you should be getting 72.96. So this, again, is just a prediction. It would not be, I wouldn't put money on it, because again, it could be above or below it. That's where the margin of error part comes in, to give you a little bit more of a range, so your prediction's a little bit, you can actually gamble on it and have some reliability in your predictions. All right, so that's step 2. Step 3 is t-table time. All right, so if you remember, our degree of freedom is 14 and our confidence level is 95. So I'm gonna go get me a t-table. So let me Google this real quick. T-table. All right, so here we go. We got the t-table, and again, we're looking at the 95% confidence level and then the degree of freedom that we just got, which is 14. So we use that 95% column, we go up to 14, and that is pretty much it. 2.145. That's all. So there is our t-score, or critical t-value, okay? That's step 3. So again, like I told you, steps 1, 2, and 3, not bad. Now, step 4, on the other hand, this is when things get a little tricky, but I promise not too bad. So let me break it down. This is called what is known as the standard error. Standard error is trying to find the standard deviation of the distances from the points to the line themselves. So each of these dots, some of them are right on the line, some of them are a little bit above or below, have a distance, vertical distance to that line itself. Those distances, we're just trying to get the, let's just say the average of that. In all essence, the standard deviation of those distances, which again is what a standard deviation is. It's the average of the distances to the mean. In this case, the mean would be the best fit line. So according to this equation, what you're going to be doing is taking each of the y values, which is your second column, and subtracting a predicted y value. You've seen that again from the best fit line equation. So you're going to be plugging some of the x values in to get that. So you're pretty much trying to find the location of the dot minus the location of the line at that same x value. Then you're going to subtract those, square them, and add them up very similar to the standard deviation formulas we learned earlier this year. So let me show you how to do that on a spreadsheet to save us some time. So at this point, I don't really need this much anymore, other than the fact that I need to write down this equation. So I'm going to write this down here so I do not forget it. So it's 1.84 times x plus 51.8. And what I'm going to do is I'm going to plug each of these x values into that equation so I can get what is known as my y-hats, or my pretty much the best fit line location of each of these values. So again, what I'm going to do is I'm going to start by getting rid of this because we really don't need it much anymore. I'm going to go equals. To start this equation, I'm going to type out the best fit line equation, but instead of saying times x, I'm going to click my first x value, and then I'm going to go plus 51.8, and then hit enter. So what this is saying is this is where the best fit line is at this x location. This is where the actual observed y value of that location was. So a guy with shoe size of 10 had a height of 70 inches. According to the best fit line, he should have had 70.2. So there's a little bit of difference between the best fit line itself. So I'm going to continue doing that, but I'm going to drag this equation down and it'll continue plugging each of those x values in. Because everything is very correlated, you should notice again, these numbers shouldn't be much different from each other, especially for the ones that are very correlated between the dots and the best fit line. The next thing I'm going to do is this part of the equation, which is the y minus the y hat and then quantity squared part. Remember, we're doing all this before we can even get to the sum part. So I'm going to call that. So it's going to look something like this, parentheses y minus y hat. Hat means a prediction in this type of problem, and I'm going to square each of those. This is just to remind me what I'm doing in the actual boxes. So I'm going to go equals, I'm going to go parenthesis, I'm going to go y minus the first y hat, and then end the parenthesis, and then square it, hit enter. Again, you only have to do it for the first one. If you drag this down in the bottom right hand corner, it'll continue that trend all the way down. So these are all of the difference between the y and the y hats squared. So this pretty much is that list that this summation symbol is having us add up. So we need to sum up that column now because we've already done y minus y hat squared. So I'm going to do the sum here. Go equals sum. That's the command for adding something up. And then I'm going to highlight all of that list. And that will be the sum of the y minus the y hat squareds. All right, so we're going to plug that number here, and then we're going to divide that by 16 minus 2, because again, and the sample size for this is 16 men. So 10.748, that again just came from the sum of that column, divided by 16 minus 2, in this case 14. You can go ahead and throw that into a calculator. In fact, I'm going to do that. I was telling you a little bit about graphing calculators, and some of you guys might have forgotten about Desmos. Desmos is great for graphing, but it's super duper awesome for calculators. Let me explain why. Number one, if you plug anything into this, it'll automatically calculate it for you. So for instance, if I did the square root of, what are we doing? 10.748, right? So if I did 10.748, you'll see automatically it's doing the calculation for me. But what's nice about this is I don't have to worry about order of operations. As long as I type it in to look exactly like it does in the equation, it will take care of the order of operations for me. So you'll notice there's the answer right there, 0.876. So hopefully that can help you. For those of you guys who don't have a nice fancy calculator, you can use Desmos for free. So there's the standard error. That's step 4, all done. Now step 5, this again, big scary equation, but a lot of the stuff we already know. For instance, the t-score we got from earlier, that was from a previous step, step 3. Standard error came from just that previous step, so we'll just plug those numbers straight in for those things. Anywhere you see an n, in this case we're going to put 16 because that's our sample size. Now the only other weird ones that we have to quickly calculate so we can plug into this is this guy right here. If you remember earlier, x with a bar over it means the mean. In this case we want the mean of the x's. This one, x with the O, you'll notice from the best fit line equation, this is just what x value you are predicting for. In this case, we're predicting to see what would happen if a person had 11.5 foot shoe size. So that 11.5 goes here. So the X with an O is going to be what X value, what's the X value that you're trying to predict for. That number goes there. The rest of this is going to just need a little bit of spreadsheet magic, and I'll show you that right now. So the first thing we're going to do is get the mean of X, and I can do that very quickly, but I'm going to do this down here. So I'm going to go equals average, and again, the first column of numbers is always your X values. This is your, what is known as your independent value, or independent variable. So this is just going to be my mean that I'll use. And then another thing that I'm going to need to calculate so I can plug in is the sum of X, right? So I can plug that in there. I already have my X's, so I just need the sum of that column. So I'm going to do that as well. Equals sum of these X values. So that's just going to be 167.5 is going to go into that part of the equation. And then last but not least, we need to find the sum of X squareds. So again, there's a big difference between this and this, where this is asking us to sum up the X's and then square that total. This is asking us to find what the X squareds are and then add those up. So that's going to require one last little column, and I'll do that right now. So I'm going to get the X squareds over here. And I'm going to do that by just doing equals, taking each X value and then squaring it. So we're going to drag that down, and it should continue all the way to the bottom with all of those X squareds. Now, the equation wants the sum of that, so we're just going to add up that column, and that is the number that will go in place in the equation. So here we go, 1,773.75. So putting it all together, I'm plugging all my numbers in. So the t-score came from, again, step 3. This one came from step 4. 1 plus 1 over 16 plus 16 times. Again, I was telling you that XO just is what the problem, what it's asking you to predict for. So you plug that number in there, minus the mean, 10.5. That came again from me just averaging this, and I did a little bit of rounding there, 10.46. I just rounded it to 10.5. And then on the bottom, you get n times the sum of X squareds. The sum of X squareds came from summing up all the X squared values. So I did that there. And then last but not least, minus the sum of X, quantity squared, and that just came from adding up the X values right there, okay? So at this point, I'm going to throw this into the equation into Desmos, and we'll get an answer. And I'd ask that you try that too. Okay, I just threw it into Desmos, and this is what I am getting. Hopefully you are getting the same thing. I am getting 1.98, so that's my margin of error. So that is the end of step 5, and that's the hardest, promise you, hardest part of these problems, okay? So step 6, the final part, the prediction interval part. So what you're going to do is you're going to take step 2, the prediction you originally got. You're going to subtract that margin of error. You're going to then take that same prediction. You're going to add the margin of error. So again, it's very similar to margin of error. You add and subtract the margin, or confidence interval. You add and subtract the margin of error to your prediction to get your final actual prediction, your interval. So putting all that together, it looks something like this. So 72.96, which is our original prediction, minus 1.98, you get 70.98. You get 72.96, same prediction, plus the margin of error, you get 74.94. So the interval is between 70.98 and 74.94. That is step 6. Is just to add and subtract steps 2 and step 5 together, and that is pretty much it. The way you write your conclusions for these look a little something like this. So there's a 95% chance, because again, this is all based on probabilities. It's not 100% certain. It's based on how certain you want to be. Typically, researchers, 95% is very common, because again, that's a very good chance. But there's a 95% chance that a man with a foot size of 11.5 has a height between 70.98 to 74.94, and the upper level math is proof of this, that 95% of the time this will be the case. So again, this allows you to make some predictions. Now, next time when we come back on Thursday, I'll do another example. Again, these take a little bit of time. In the meantime, the assignment has really just 2 problems for you to try. Again, these are longer problems. So try doing the first one along with the one that I'm doing right now. This will be very helpful to kind of get each step along the way. It's hard to memorize these steps. So trying to do this slowly the first 2 times would be really awesome. And then I'll show you something cool on Thursday that you can do this. In a sense, we'll predict the future. I'll tell you more about that later. Anyway, if you have any questions at all, we only have a few more office hours, 1 to 2 every day up until this Thursday. You guys have a wonderful day, and thanks for listening. See ya.